Welcome to the fourth part and last part of section 2.2, the derivative as a function. We just saw that third derivative. We could go even higher than that. Fourth derivative is the f with 4 primes, but since writing that out tends to be a bit on the more confusing side, we tend to use this notation here, f with a 4 kind of as an exponent in parentheses. So in general, the nth derivative of f is denoted by f to kind of this power with n inside parentheses from differentiating n times. So this means the nth derivative of y is equal to the nth derivative of f of x, which is equal to d to the ny divided by dx to the n. And the last example we are going to do here is to use this graph to estimate the value of each derivative. And as you can see, we have a whole bunch of ones. The easiest ones to do are actually B and F. So what are B? What are F? And that's because both of those are at the vertex of those appropriate curves, right? Because of that, both of these are going to have a slope of 0 for the derivative of the tangent, for the slope of the tangent line. So both of these are zeros to begin with. But to find then these other ones, we're going to need a few points on here. So let me draw a few of these out, just so that way we are able to have these different points for us to use for this, and also be helpful for us to know what on earth we're talking about. So I'm going to call A this first point over here. We have B down here, C, D, E, and we could do F here, G, and H. So the slope of A to B. The slope of A to B. If we find that calculation, we get ourselves a value of, excuse me, I need to give you the point. For these different points, these points are the following. A is the point negative 3.8 about, comma 0. B is negative 3, comma negative 1.2. C is negative 2, comma negative 1.7. D is negative 1, comma negative 1.4. E would be the point 0, comma negative 0.5. F is the point 1, comma 1.6. G is 2, comma 3.3. And then H is 3, comma 2.6. So to get for A here, we are going to do the slope of AB based on these 2 points. Doing that gives us a value of negative 1.5. So between A and B, we have ourselves a slope of negative 1.5. We need to approach B. So that slope is going to be decreasing there. Excuse me, the slope there is going to be increasing there a little bit, since even though we're going down towards B, it's not, the slope isn't going to be as high as it approaches where that vertex there is. So a good estimate for this, since we're going towards B, the slope is going to be increasing here a bit to be about -1 as an estimate. We already have the value for f prime of -2, which I labeled here as a point here of C, so we're not going to do that one. But we can do the next one here of f prime of -1. So this will use the points of C and D. So based upon these 2 points, when we calculate the slope, we will get ourselves a slope of about 0.3. So again, we want to approach that point there of D. And the part to make note of that is, it doesn't increase too much, right? We got a slope here of 0.3. A good estimate for the slope at that point would be about a half. For 0. So at this point right here, which I noted here as E, we are going to do the slope of, in this case, D and E. And that gives us about a value of 0.9 as we approach this point here. So we do expect that slope to be increasing because the graph is getting steeper. The estimate for that would be about 1.5. For f prime of 1, this would be between E and F. The slope involving E and F, these 2 points. We would get ourselves an answer of about 2.1. And as we can see, that's increasing, getting a lot steeper. So as we approach that value, this slope would be about 3. Again, we have the slope at 2 already because that's 0 due to that tangent line here. For f prime of 3, that one is going to be the slope involving G and H. And if we do that one, we should get an answer of about -0.7. Again, we're going down towards it. So the slope involving that, a good rounded estimate for that would be about -1.5. Let me know if you have any questions or concerns. Thank you.